lot of work that impacts, the local industry as well as academia. So I think we would love to have Bosch as part of our.
Sure.
I will share. I'll connect and share more details with you, Kiran.
Sure, Neeraj. We'll do that.
Yeah, no, that'll be good, because right now apart from this WinTalk series, we are working with two other programs with HYSEA. One is called Curriculum Mastermind, where we are actually looking at how the curriculum can be impacted. And as a pilot, we have taken up 7 institutions where we are trying to see, basically the thing is like what our discussion also was that day, when we have visited your office, it was that people in the product company, right, don't find our students suitable because they haven't done too much of coding. So services industry is still able to benefit from these students here in Telangana, but product companies are not. So that is one part of it. And second thing is, majority of our faculty members are freshers, right? They go straight from college to teaching. So we started Project Drona with HYSEA, which is a faculty immersive experience. So they work on industry-related problems. They shadow the industry for 2 days, and it's a 4-week, 8 weeks, and 12 weeks kind of a tenure that we are looking at. So faculty internship, loosely.
Faculty, yeah.
Is it similar to? Typically, most of the universities have this program called Faculty Development Program. Is it similar to that?
Yeah, it's similar to Faculty Development Program, and we use the Infosys Springboard platform to train the faculty. And we also have mentors, where they coach these faculty members if they get stuck somewhere, because these are all emerging technologies that they will be training in. So we have mentors from the industry, not only from Infosys, but other member companies also. They have volunteered mentors who will be helping these faculty wherever they get stuck or wherever they need some handholding.
Oh, okay. Nice.
It will be a total immersive, and some of these faculty will also be invited to IT companies so that they can spend a day or two to understand actually how the workflow happens in a IT company. It's a very new initiative, and I think it has got tremendous response.
Yes, nice to know that. Yeah, should we get started?
So we will start in a minute, 3:05.
Yeah. Yeah. Just give me 30 seconds. I'll just grab a pen and paper.
Sure. And also a cup of tea if you want. Rakesh will be starting now.
Yes, sir. It's already on streaming started.
Streaming started? Okay. A very good afternoon to all of you. This is SHRIKANT SINHA, CEO of TASK, welcoming you to this webinar today, a part of the WinTalk series that we are running along with HYSEA since March this year. And we have done on multiple topics, and we looked at different industry verticals. And that's where we thought that let's now start also looking at industries and how industries which are not typically treated as IT industries, but IT-enabled industries, etc., how do they look at technology itself? So we'll talk about that later on. But before we start, we have an expert with us from Bosch itself, which is the #1 organization as far as mobility is concerned, and tech mobility. If you look at it, how software engineering can be used in mobility, and that's where we have our expert today. But before we move on to that, just a quick helicopter view about TASK. While I welcome all the college management, the faculty members, the HODs, the TPOs, and the students to this webinar. As you know, we have 718 colleges plus. We have skilled close to 680,000 plus students, 15,000 faculty members. Recently, with HYSEA, we launched multiple programs to help develop our faculty members further. The main aim is how do we make our students more employable? And we feel that faculty members upgradation also is as important. So before we start, over to you, �𝗎𝗔, to talk about HYSEA, which has been our partner for long and a very strong partnership.
Thank you, Shrikant. It's always a pleasure introducing HYSEA for me. It's a privilege, in fact. HYSEA is a unique ITES industry body that is almost 30 years old now and has more than 300 plus registered members, representing more than 90% of Hyderabad IT industry in revenue as well as in employee headcount. And one of the, well, our primary focuses since our inception has been policy advocacy, protecting the interests of IT and ITS industry, and promoting Hyderabad as a preferred destination for businesses to grow. But one of the key focus areas for us has been how we can improve the employability of graduates from our universities, students graduating from our universities in Telangana, and then it was even Andhra Pradesh. That has been one of the key focus areas. And over the years, I personally have worked on various initiatives along with TASK, whether it was Makerspace, Excite program, hackathons, internship fairs, job fairs, and we have done several of these initiatives. And WINTalk series is part of that effort, where we want to bring emerging technologies and what are the opportunities that are out there and what students can do to be job ready. Because we're targeting third year and fourth year students, we want to share information with them, clear the clutter, because there's so much information available on the internet. We want to make some things clear for students, what is expected of them when they graduate, if they want to make a career in a particular technology area. So WINTalk series is a big effort towards that, improving the employability of students graduating out of our colleges. I'm very happy to work with TASK as always. And Shrikant mentioned about Curriculum Mastermind, Project Drona, and we did a wonderful program yesterday called Ignite Spark, where we'll be focusing on young women from engineering colleges as well as other degree colleges, and hand-holding them, coaching them about how they have to make a conscious career planning. I know education is not just about graduating and getting married. We want them to plan their careers, consciously plan their careers. And we were so happy with that. Within 2 days, in a short notice of 2 days, we had 22 girl students from 4 tier 2 cities participating in HYSEA office in one of the best conversations I have been part of. So thank you, Shrikant, to Shrikant and Sugunakar. They were so quick in arranging this session in HYSEA office. And we will continue to work with TASK for the benefit of students. And I won't stand between our session. I'll hand it over back to you, Shrikant. Thank you.
Thank you, �𝗎𝗔. So we were having this discussion with Kiran in his office, and that's where we decided that we should do a session on software engineering and mobility solutions. So without any further ado, I would like to welcome and introduce our expert for the day, Mr. Kiran Sundararaman, who is the Vice President for Bosch Global Software Technologies. He's also the Center Head for Bosch Global Software Hyderabad. He's also the Strategy Head for Global Delivery Network itself as part of Bosch Global Software itself. He has got over 27 plus years of experience at Bosch across mobility, software engineering, digital enterprise, business services, and that too across multiple industry verticals. By training, he is a Bachelor of Engineering in Electronics from REC Nagpur, which is now, of course, NIT, and Executive MBA program from IIM Bangalore. if I look at his interests and hobbies, it's music, cooking, and cricket. So welcome, Kiran, and let's understand what is cooking as far as the future of mobility is concerned. So let's start with that first.
Sure, Shrikant. Thanks for that lovely introduction. It's an honor and privilege for me to be part of this WINTalk series. We had this conversation a month ago, and I'm so glad that I'm already here to participate in a platform which is being provided by both TASC and HYSEA. The idea of such a session is not just disseminating information. I think it's more important as a community and as our responsibility to ensure that the academia and the industry come closer. And one way to do that is to have constant communication back to the academia, and it's a dialogue basically. So I would imagine during the course of this talk as well, I would want to have an engaging conversation, and it need not be just a one-way information exchange. I'm really excited to be part of BGSW here in Hyderabad. So we are the new kid on the block, but nevertheless, I will come to that part later. So coming to your first thoughts on future mobility. Actually, we see mobility is changing rapidly, and it is basically being dictated by the global mega trends that are there, right? So if we are talking of global mega trends, we now see connectivity is almost like a fundamental right in whatever we do in our any walk of life. Yeah, that is one mega trend that is there. The second one being urbanization. I think globally, we can clearly see that most of the world's population is going to move to the cities. So nearly 60% of the world's population will be in the cities in the coming future. And even the demographics, of the population is changing so rapidly. And this also has an impact on the society. And by no means we can ignore the impact of all these trends on the energy and the climate situation that we have globally, right? So when we look at these large mega trends, we clearly see that it has an impact on the way we view mobility as a focus area. Yeah, so we can clearly see if we take from a climate change perspective, we are moving more and more away from the traditional powertrains, which were based on internal combustion engines. We are moving more towards electromobility. That's one mega trend that we already see. Yeah, and the second one, if you're looking at is whatever internal combustion engines we have to make them more cleaner, more efficient. So which means that our powertrains that we drive in automobiles, they have to be much more efficient, right? Having said that, it's also about the user at the end of the day who drives a car or a vehicle. We see that there are new emerging technologies that are there, autonomous driving or driver assistance systems. These things are becoming a very hygiene factor nowadays. Yeah, so that's another important aspect of the way mobility is changing in itself. And also things like the peripherals of a car. Actually, if you see earlier generations used to think of having a house or a apartment to live in. Now most of the people don't mind even living in cars. So a lot of things have changed. So connected mobility is also becoming a reality, and we see that behind all these mega trends, there is an underlying focus on technology, right? So it is the technology and the power of technology that is enabling all these mega trends to be lived in a more cohesive, in a more cleaner way. Yeah. So while we talk about the mega trends broadly, we look at the trends in mobility itself, we have categorized them into 4 buckets, yeah, as far as Bosch strategy is concerned. So we're looking at personalized. I think this was a very important aspect. Pre-pandemic, we all knew that most of the things that we wanted to do, we wanted to switch to shared services, even in terms of mobility. So we had the Ubers and the Olas ruling the world pre-pandemic, but post-pandemic things have changed a little. The shared car concept is now moved to a more personalized one, right? So while sharing a vehicle is still going to be the order of the day, but there's a certain degree of personalization that the user wants. And so personalization is one major area, yeah, in terms of the trend in mobility itself. The second pillar that we are looking at is automation or automated vehicles. So I think whoever started the Star Wars in the 60s and 70s, what we saw in the Hollywood movies is becoming a near reality. So automated self-driven cars is going to be there, but we have to see what is the applicability of automation, what is the level of automation that we desire to have in vehicles. That would entirely depend on the market, the ecosystem that we are living in. And this could vary from country to country, region to region, globally. Yes, but nevertheless, automation is here to stay. Yeah, so that is very clear. And as I mentioned, connectivity is becoming like a fundamental birthright, right? So a kid who is born today would like to have a mobile next to him, even before he wants to have a spoon of food. He's looking at the mobile or a device. So connectivity is becoming so much ingrained into our day-to-day life that even it doesn't spare the mobility space as well. So we will have a future where cars are talking to each other. Yeah, so connectivity becomes a connected vehicle, or vehicle to vehicle communication, or vehicle to cloud communication becomes very, very important. And as I mentioned earlier, it's about having a cleaner, a greener planet, a cleaner, fuel efficient way of delivering mobility solution. So electrification is definitely there on the radar. It's near reality now. It's only a matter of time when we will move to more and more efficient electrified solutions. Yeah, we do still have challenges on the electrification, but those challenges are something that we can solve with the use of technology. Yeah. So broadly, I would say, if you look at it, these 4 elements of the strategy drive our future mobility. Now, when I'll pause here because I think the next set of topics that I wanted to also talk about goes in the direction of how these technologies, or how is technology enabling these trends that we see in mobility.
Thanks, Kiran. In fact, yes, it does look like something from Star Trek, etc. But again, that's what it is. Things are moving in that direction itself. And when you spoke about connected or autonomous, etc., I think already things are moving towards that direction with 5G coming in, fleet learning, and all these things are going to be reality. So my only thing is that we are all predicting all these things. And of course, at one time, Bill Gates had predicted himself, being the founder of Microsoft, that the maximum RAM that anyone could require at one time would be 64K. And rest is history that, today our mobile phones have got at least 1,000 times more than that, than what Bill Gates had predicted at that time. Yeah. So what is the, probably if we can say, what role does software or technology play in this entire scenario that you have painted? And what is the, right? So how do you, what makes you gung-ho about these predictions, and what is the role that software or technology is playing?
Excellent question, Shrikant. I definitely want to go a little more deeper into this topic because it's very close to my heart. When I started my career, I was just an engineer in the electronics.
Just one second, just one small thing. Kiran, just one small thing. Just let me intrude for a second over here. Right. So while Kiran continues with this question, I would request all the people who are there on this webinar today, please type in your questions so that once my questions to Kiran get over, we can pick up your questions. So I will repeat this after every question, but please start putting your questions, for Kiran so that we can answer them later on. Sorry for this interruption, Kiran. I should have done it before I handed it over to you, but better late than never. So over to you, sir.
No problems. Thanks, Shrikant. So this is a wonderful question, and I think this is the crux of the topic today. Yeah. So it's very close to my heart because as an engineer, I started my career as an electronics engineer, and then when I joined the industry, it was like jumping into software where we didn't really understand what is software. With about 2.5 years of realization, 2.5 decades of realization, I would say, software is nothing but common sense, if you ask me. Yeah. So how do we apply common sense and make things work? And that's what a software engineer will end up doing in the future. So it's about applying the common sense, the logic, the intellect that we have to solve real life problems, real-time problems. So if you actually look at the way software is becoming more and more integral to any mobility topic. So if I take mobility in itself, the classical wave that we started was, where we had functions and features which were getting developed, and these functions and features which were engineered were more hardware centric. So in the 90s and the first 2 decades, or I would say first 1.5 decade of this century, I would say most of our action was on the functional aspect, where we really spent a lot of time on implementing features through a combination of hardware, which was more hardware intensive, and then software was more of an enabler. Yeah, so you would still have a sensor, you would still have an actuator, which would help in controlling certain functions and features, and that's how we started our journey of introducing electronics. Yeah, and electronics predominantly was hardware driven. So now, over the last decade, I would say that between 2010 and 2020, we saw the advent of new technologies like, you have connectivity, you had Internet of Things, we had different kind of mobile apps that were there, and we had, it was important for us to explore the possibility of finding the intersection of technologies. That's where most of the innovation happened. So in the digital world, we try to adopt some of the digital technologies into a mobility kind of a space, right, as a domain. So we clearly saw enhancements happening on the infotainment side, for example. It became more digital. Earlier, we had a car radio with a knob, with a physical hardware, which was you could touch. Now we saw that in the digital realm of things, we could see that the infotainment itself was a new experience altogether. You have touch screens, you have mobile connectivity, you could connect your USB, you could connect your devices in a vehicle. So that already is the first step towards digital transformation that is happening. Yeah. Now, as we move ahead, we can clearly see that hardware is becoming less and less important from a user standpoint. So it's all about putting the user in front, user into the center. And if we look at that, we can clearly see that the core domains will continue to exist and will operate on a hardware and an operating system, which the user actually doesn't have to bother. So he needs user experience. He needs to make sure he has more comfort features. So we are moving away from a digital space which had limited updatability to a more advanced way of updating things into a vehicle. So imagine, I don't know if you can relate to this. Imagine that you are driving a vehicle and you get stuck on a highway, and the problem is probably because one of the sensors might have to get reconfigured. Now, you wouldn't want a service technician to figure out his time in the traffic and get to the location. It would probably take hours together for him to reach there and fix the issue. Imagine a situation if this can be solved over the internet, and we are able to connect to the vehicle over the internet, and we are able to update the software which is embedded in the sensor, and the sensor gets corrected. Yeah, so this is the new reality. So that's where we are talking of Vehicle 3.0, where we are looking at abstraction of hardware, updating our actions on the ground. Yeah, so that is the trend that we already see, and the new age manufacturers are working very strongly. You have the Teslas of the world, you have the Daimlers, you have the Volkswagens. These guys are really making headway in a big way to see to it that a vehicle can be updated without really going to a service station or taking it to a repair shop to fix it. Yeah, so that's the power of technology that we want to use. And having said that, this would drive the future mobility more towards a software-defined vehicle. So the abstraction could go to an extent that we really don't have to worry about the hardware anymore, but you develop all the features, as many features as the users would want, make it as configurable as you want. And software is something that you are able to, just like you download a mobile app, we should be able to upgrade the app on the vehicle, and the vehicle is an upgraded version of what it was earlier. So that's the kind of technology shift that we are seeing. And Vehicle 4.0, if you have to define that, it will be more software defined. So that's why I say that software engineering becomes even more critical, yeah, as we go forward into the future of mobility. So you will find most of the action happening in the software space. I wouldn't say that hardware will go away. Hardware is still needed. You need a vehicle to drive from point A to point B. But the features that you want and the kind of compute power that you require to enable those features are going to be more software driven. Yeah, so this is the way we see that the future of mobility is going to take, with software which is going to lead the innovation path. Yeah, so that's the way the mega trends are going to emerge. Yeah, having said that, now we come to a very important aspect on what kind of how is this software-oriented vehicle going to look like? So we are looking at a strong increase in the functional requirements of the future vehicles, combined with a differentiated consumer or user experience. And the entire value chain that we talk about, there are mega shifts that are happening in the value chain. Right from if you talk about right from the supply chain to actual vehicle getting delivered, that whole stream of value chain is undergoing mega shifts. Yeah, so when it comes to developing features, we clearly see that connectivity, as autonomous, which I already talked about, the PACE strategy, that's where that is going to get onto the vehicle. Yeah, but how do you now deliver this as an experience to consumer, right? How do we ensure that most of the things are available on a smartphone? Can I do a remote start of a vehicle? Yeah, is this possible at all? Can I switch on the vehicle even before I get into the vehicle? Can I unlock and lock the vehicle by sitting in an office space or at home? These kind of features are something that the consumers would be expecting, and there's a lot of technology enabler that happens through software. Yeah, and the value stream that I talked about, or the value chain, if you look at it, the software becomes a kind of a fundamental platform on which all these different aspects of engineering are going to be driven. Yeah, so this is the way software is going to now define the future, how a future vehicle would be created, would be manufactured and delivered as an experience to consumer, right? So that's the software content that I would imagine from a technology standpoint that will go into the mobility space. Shrikant, are you there? I think we lost Shrikant, but then probably we can continue. Pani, are you able to hear me?
Yes, Kiran, we are able to hear you.
So I think we lost Shrikant for some reason. So
Maybe, madam, there is some network issue, so we will back in.
Sure, no
like
problem. Then I'll pause here. I think the next set of slides or information that I wanted to share more is towards what kind of software competencies that we would require. So when we talk of software engineering as it is relevant to a student or a graduate who is currently pursuing his engineering, I think it is important to understand what kind of capabilities you would need to pick up early enough in your career, in your professional career. Even when you're studying, I think it's important to focus on certain aspects of software engineering, which becomes very important. So I would talk a little bit about what kind of capabilities we are looking at. So traditionally, when we spoke about a traditional vehicle getting developed, we clearly see that the kind of technology changes that are happening on the mobility front. It was more hardware engineering, it was more software enabling the hardware engineering, so which would mean that you need to understand the entire software engineering life cycle like a V model. I'm sure most of you would be studying this in the course. So if you know that, that is already a very basic hygiene that most of you would anyway have covered this, and that is good that it is already integrated into your curriculum. Now, specifically, if you're talking of the automotive space and the automotive control system space, we clearly see that electronic control units would be all microcontroller based, and the trend that we see is from a microcontroller based, we are moving more towards a microprocessor based platform, which means that the reason to do that is that the demand in terms of the complexity and the compute power that we require, there is almost 100x shift in the compute power that we require. So that's the reason why we are able to now move to focus more on a microprocessor based system than a traditional microcontroller based, which has slightly less on the compute and also less on the memory requirements and so on. So the one major change that we see is that I think in universities as well, it would be very useful if the universities and academic institutions offer courses around microprocessor. I'm sure microprocessor, the basic microprocessor that I studied was 8085 and 8086, but I think there are many more new processors that have come when it comes to new technologies that are there. So I think it would be really worthwhile if the universities can also start focusing on microprocessors which are more advanced in their capabilities that should be introduced in the courses. Having said that, I think operating system, real-time operating system, these are all basics that are expected that define the software architecture, right? So we are actually, if we see the evolution of automotive software architecture. Now we are moving away. So real-time operating system is something very close to the hardware. So that's why I said, as a software engineer, probably, people who are very close and passionate about hardware, they need to know a little more on the software side, especially on the operating system side. And those control algorithms, which is close to physics or mechanics of an automotive, that is something that would be still core of a product like a vehicle. But I think the innovation that which will be led in the future mobility will be more software intensive. So programming, cross-domain application, and the different types of operating systems, the virtualization, the visualization, the connectivity part, these technologies become even more important. I think SHRIKANT, now you're back. We had lost you for a while.
Yes, unfortunately, while we were talking about all these futuristic things and how things will be software dependent, and you could upgrade your car. So I was hearing everything, but I don't know why. I am speechless. So, but anyway, please carry on. I believe the various the competencies, etc., required for that. So, Kiran, I think that would have a question.
Sure. Yeah. So I was trying to cover what kind of software capabilities or competencies we still expect on the mobility front. So all these things, what you see on the screen today, are very much relevant for mobility. So if you are working on the cloud, if you have a cloud certification program, please go ahead and enroll for that, because cloud is also relevant for mobility. Or a mobile app development, that is so much related to connectivity, and in future mobile apps would be able to control how a software functions in a vehicle. At the same time, if you look at it, with such increasing complexity and abstraction of software driving the innovation, we see that you also have a threat to a vehicle if you can hack into a vehicle. So cyber security and an embedded security or product security becomes even more important in the new context. So imagine you're driving and somebody hacks into your car and he's able to take control of the vehicle. That can be spooky, right? And you can encounter any of these challenges if you're not able to secure the vehicle. So the software is which was an enabler becomes the core now, but we also at the same time have to ensure that everybody is safe in a vehicle, and that safety has to be provided, safety net has to be provided through, again, cyber security and software. So as I mentioned, any of these technologies, what you see on the screen, will have a major role to play in the future of mobility, in the future where software is going to define a vehicle. Yeah. So I think we don't have to worry. The software engineers, mechanical engineers, hardware engineers are very much still relevant. The degree to which software is pervading or invading into our life in a mobility context is immense. And I think any of these capabilities, if we are able to pick up, the relevance of those capabilities is very strong. And I would imagine that this is something that is going to be here to stay at least for the next couple of decades. So that's what I could say about the capabilities. And if we are talking about the new competencies that we expect, I already spoke about the trend of moving away from a controller to a microprocessor-based system. Our future electric and electronic architecture is going to be more distributed than a centralized approach. I talked about cybersecurity. We talked about AR, VR, visualization, augmented reality, AI, ML. So if you're talking of automated and autonomous driving, the machine intelligence that we build into a vehicle, you have to make a vehicle intelligent, and the vehicle can gain that intelligence only through artificial intelligence. So with machine learning and AI algorithms, we will make the car learn more about the environment, and thereby, when you're doing an autonomous driving concept, these technologies become the core. Yeah. So I think there is a clear shift in the way technologies will be used to secure the future mobility itself. So this stable standard things will be part of the stable technologies, and we clearly see that the complexity of the vehicle is increasing. So there's a certain set of technologies which can be clustered into the complex group, and the chaotic or the randomness that you see in the future of mobility can be actually brought into some kind of a well-defined, software-defined vehicle. That could happen with the emerging technologies of AI, ML, big data, and deep learning. So on that note, I would pause here. I think it's been a monologue from my side. I'd be happy to answer questions if there are questions on the chat box, or if somebody has already posted this. Shrikant, I would request you to pick up those questions, and we can try to have a quick dialogue on that.
Not able to, can you hear me, Kiran?
Yeah.
Okay. So thanks for that deep dive into the different technologies and how things would actually change, and how that would happen. But also probably what I would be interested to understand is what could be the different job roles. You have spoken about what a person should be knowing, what are the skills, the competencies, but what could be the job roles also for these students?
Yeah, so very interesting question. So yesterday I was just going through my Instagram, and I found that there was a funny video by one of the RJs. So the new roles, and this RJ clearly said we don't call ourselves a software engineer anymore. We are called techies, right? So you can be a technocrat, you can be a tech evangelist, or it could be anything related to tech, because technology is becoming a little more centric, and there is a lot of enthusiasm that goes along with technology. So if you look at the future technologies or complexities that are emerging in the systems, the kind of roles that we see are also going to change dramatically. The classical roles of having a project manager, a software engineer working in a project, and project getting delivered on time, on cost, and on quality, those traditional roles are going to definitely exist. What we clearly see is that the so-called management of workforce, I think this might undergo a major change. So as a software engineer, as long as you are relevant when it comes to technology, the role that you would want to play would obviously get defined by the capability on the technology front which you pick up and choose. So you could be an AI ML expert, or it could be a cloud. You could be a cloud expert, or you could be a blockchain expert. So any of these. So the expert career path, I would say, would throw up all kinds of roles. The roles will be closely associated with the tech stack that you will be working with. Yeah, so you could be a programmer in AI ML as a role, but you could also be a programmer, say, in a blockchain, or a deep learning programmer. So, excuse me. So I would say the roles will also evolve over a period of time. We are in the phase where the complexity would actually define the roles. Another important aspect, what we see is with so many technologies coming in, the innovation is happening at where the technologies intersect, right? So it means that we need to have stronger understanding on how to integrate the system. So the role of an integrator, a software integrator, becomes even more important because they need to understand the complexity on one side and also different technologies and how these technologies interact with each other is where a very major role will be played by an integrator. So a software integrator, a software programmer, those roles become even more amplified. And I think the software programmer cannot be a generalist anymore. He has to pick and choose one or the other technology domains, be it either on the front end, back end, it could be on the cloud, or it could be AI, ML, or it could be a big data topic. So in all these technology space or tech stacks, you will have similar roles coming up. But I think as we move at higher levels of software abstraction, the software integrator roles become more prominent. I would imagine in a decade from now, you would have more self-organizing teams. More collaborative approach is going to be taken by different software engineers from different streams, and thereby the need for, say, a manager or a generalist would become less as we move forward. So a generalist role will not be valued so much. It's more important to be associated with technology. It's more important to be staying relevant with the changes in technology. That's the way I would imagine that the roles would get defined. I think we have lost SHRIKANT again. Neerja, are you able to see the questions on the chat box? If there is any?
I'm using my colleague's laptop. I think Murphy really decided to show its best at the worst time. So while I will come with some more questions in the end. The questions that we have from Rishank is, what is the best model to build the software?
Good question. So Rishank, my take on this would be that the way software engineering is getting redefined, the models will also change rapidly, right? Yes. So now in the past, we were, for example, doing a traditional classical V model where you would have the requirements engineering done, then you would go into the detailed design, high-level design, low-level design, you do the coding. The classical V model, I think all of us know. But now I think the need for us to do the design has to be at a much rapid pace. So you will see that is getting replaced by model-based development already. So the change that we see is that on the front end of the V model, we see that the engineering part is done using modeling software, right? So you use software to design your requirements, define your requirements, design the actual architecture of the function and the feature, and through software we are able to generate the code as well. So the need for a classical programmer is becoming less and less, and through model-based engineering, you're able to kind of eliminate the need for us to sit and know the syntax of a C program or a C++ program, because the machine or the software can get generated automatically. So auto code generation would kind of replace the actual coding activity, yeah. So which would mean that a software engineer has to up his skill to understand how to do model-based software engineering, yeah. So on the other side of the V model, it's about doing the same thing on the testing. So how do I simulate the requirements? So you will again do model-based testing on the other side of the V model. So that's a big shift that is happening in the industry today, moving away from the classical step-based approach to a model-based approach, which would reduce the cycle time of the development. So classically and traditionally, we used to take at least 2 to 3 years to bring up a new version of a product in the mobility space. Now that is no longer the case. We are trying to crunch the development life cycles into, say, 3 to 6 months, where I want to be able to hit the road with the final feature which users should be able to start using. So there are different approaches that are available, and I can see that this model-based engineering getting more and more strengthened. And as we move, as we start adapting new technologies like connectivity or IoT, the kind of DevOps that we have to do, so the developer is also responsible for testing. He no longer can say, I cannot do the testing, somebody else has to do the testing. So the DevOps is also about development and managing the ops, right? So that is going to change. So we are talking about agile DevOps, right? In a very, very short span of cycle, a development cycle, I should be able to build a feature. So these are the different models that are emerging. And I would imagine as we move, as we start adopting new technologies, there'll be new models that would also come, which we should be aware of and we should be open to learn. Yeah.
Okay. And of course, if we look at the traditional, you rightly said, software 2.0 is already coming in a big way, where auto-generated code would be there. Earlier, we used to have WYSIWYG reports used to get generated on its own, but now, of course, application of all the technologies is going to make software also generation on their own itself. So syntax, etc., is not that important. It is the model what is there. So the next question is how to find the size of the software product. I'm not sure, probably, what do you mean by that? Are you talking about the software product in your car or something, or I'm not too sure.
That's a good question.
Would you like to take a go at it?
I can try to answer this. So earlier we used to say software product or software that goes into a vehicle is measured in lines of code that we write. Right now, no longer. I mean that is one measure of size. The number of lines of code that we write, or finally an executable that you would generate would have a kilobyte or a megabyte that would get downloaded onto a control unit. Now the measure of size is probably features. How many features can I build, right? That's the new way to look at it. And the lines of code is the underlying layer, and that is already abstracted by software, the model-based approach where autocode generates, the lines of code. So it's more important to measure the size in terms of the features. So it could be feature-based sizing that we do. And the development time also is going to be estimated in how many features can be delivered in what amount of, with what amount of effort, and thereby we arrive at the timelines to develop a feature within from a start to an end date. So that's the way that things are changing already.
Absolutely, I think very well said. It's the features which will matter. And when we talk about features and how things are happening, the next question from Lokesh talks about what is the difference between bug and error. And while we are on that, because you spoke about cybersecurity and everything else also coming in, wanted to understand from you, because recently all of us heard and read in the newspapers about the case of unfortunate incident of 𝗬𝗪 and then it was said that the black box, which we always thought was in a plane only, that the black box is going back to Germany for it to be decoded, trying to see what went wrong. So what all data is actually being, the cards are reading and that is being sent to different places without our knowledge.
Yeah, very, very important aspect of mobility, right? Fundamentally, or traditionally, I would say we were more looking at vehicle as a means of getting from point A to point B, and we have to ensure the safety of the individual in the car, right? That doesn't go away anyways. be it an aeroplane or a vehicle that you use for moving from point A to point B, safety is the most important aspect. Safety of the passengers, safety of the co-passengers, the driver, and people on the street as well. So if you look at the way future technology is going to look at is, I should be, if I'm doing self-driven cars, I should be able to detect an obstacle on the road. It could be a cat or a dog or an animal or a human being, right? I should be able to figure out, is it a innate object or is it a mobile object? And I should take precautions to prevent an accident, right? So now if you look at it, I go back to the question, which is very interesting. What is a bug and what is a error? So anything that doesn't comply to a defined requirement, that's the classical definition of an error, right? Now, when we talk, and on a lighter note, if you're not able to fix the bug, then you can also treat it as a feature. Now, the feature, the way I see it is the way features are going to be handled is that you have a clear expectation, and that feature's expectation, if it is not met or complied with, that would be a deviation. Now, the extent to which the deviation would happen would be determined by the impact it has on a life, right? So if you say there is a car crash, an airbag has to get deployed in milliseconds, right, from the point of impact. And if there is a bug there and the airbag doesn't get deployed for whatever reason, now I think the explanation that partially was given, I might be wrong, but I'm just making an assumption here in case of Mr. Cyrus Mistry, was that the pillion seated people in the back seat were not wearing their belts, the seat belts, and probably that's one of the reasons why the airbags didn't get deployed in the right way, and the impact was, fatal. Yeah, so it's very important, even though that feature exists and is designed to operate in the right way, there is still a dependency on a few other factors that are there in the vehicle that would determine the context in which those features get enabled. So in this case, since the person was not wearing a seat belt, maybe the car assumed that there was nobody in the back seat, right? And there's all likelihood that the airbags didn't get deployed in the right way. Even though, if you take a Daimler vehicle, they have highest level of safety that is ensured, but it was very unfortunate that the accident proved to be very fatal. So that's why I said every feature that is designed in a vehicle is thought through from all the aspects of safety, security, and when we say data, the huge amount of data that is being computed in the vehicle. So vehicle has got multiple computers that are there. And this amount of data that we deal with is immense. And when we talk of a black box, the black box is basically there to track critical events that are happening in and around the vehicle. So that amount of data is something that the black box is able to record, but you can actually see gigabytes, terabytes, megabytes, all kinds of bytes of data that is available on the vehicle. And the future is that most of this data should not reside in the vehicle, but it would be probably there on the cloud. Yeah. So if we're talking of such volumes of data being anchored in the cloud, then who takes care of the security of this data on the cloud? So again, you would want technology to help us secure that data, right? So if somebody were to hack into the cloud and were to tweak the speed of a vehicle, instead of 100 kilometers per hour, if somebody hacks and says, okay, now the car should move at 200 kilometers per hour, but somebody has to detect that there was a hack and immediately take corrective action and prevent that hack from happening, and on the real-time basis. So the impact is on real time, right? Because your vehicle is in motion, and that is something that can be very, very fatal and serious. So that's the reason why we say that these technologies, even though they are getting adopted very, very easily, the focus on security and safety increases at least tenfold, right? If not anything. We have to make sure that each of the future vehicle functions that we design are designed with safety and security as a prime focus.
Right. So the next question is of course something similar to what we spoke about, but Varshita wants to know the difference between risk and uncertainty.
Yeah, so risk, the way I see it is something that is defined, measurable, yeah, and you can take an action either to prevent it, or if the risk occurs, you can mitigate it through an action which will reduce the impact. That's the way I see it. If you go to the other extreme, if I don't know a particular context and a condition that could occur, then you're talking about uncertainty. So uncertainty doesn't have a measure, but I think when it comes to risk, we can measure it. We can plan preventive and corrective actions, and I should be able to mitigate the threat of that risk occurring. The threat of an uncertainty and acting on an uncertainty part becomes a lot more challenging. So it is important to translate that uncertain situation into a risk. Thereby, you should have more controllables.
Yeah, as they say, over here in Hyderabad, if you're trying to get an autonomous car to drive, because you have people who are on the phone and you don't know, sometimes they go right, sometimes they go left. I don't know what will the autonomous car do. This is the case of pure uncertainty, which way the person will head. If it tries to think that it is moved.
On a lighter note, I think India has got very advanced technology, right, on the road. I call it the dynamic lane allocation.
Dynamic lane allocation, interesting, yes.
Just to put a technical term to it, we don't need autonomous cars. I mean, it will take a while for us to really start using autonomous cars in India. The fuzzy logic of how a driver drives his vehicle on the street, actually, it's going to be, it's going to require a huge amount of continuous learning, deep learning, and deep learning to really figure out how I'm really surprised if artificial intelligence can really solve the model of Indian roads, yeah, or the drivers on the Indian roads. So it's going to be a huge challenge for us. But nevertheless, I think what we should be always aware of is that the context in which we are going to use these vehicles, which are autonomous, that could be different, yeah. So it could be, so we might require new measures on the infrastructure side, and also you can restrict the level of automation that you would desire. So for you to drive from on the highway from, say, Bangalore to Hyderabad, even if you attempt to even go on a simple basic cruise control, today it's within 50 meters you're back to your manual driving. You can't cruise at all because of the volume of vehicles on the street, the kind of obstacles that you don't expect suddenly.
Right.
So technology is there to solve problems, but India has probably got different set of problems that we need to address, and then technology can be adapted.
Yeah, probably we should, and that's where my 2 bits on this is that since ambulance is always a problem on the roads, we don't have ambulance lanes, we don't have any of these things. We could have autonomous flying ambulances, which could actually, help in evacuating people instead of traveling through roads, etc. That could be a good application of this kind of a thing. Now, Soumya wants to know what is the use of baseline.
So I'm assuming that it's in the context of a project, or I mean, how do I read it? Are we talking about software itself as a baseline?
Correct.
There could be multiple things, right? If you're talking of planning from a project management perspective, baselines are always needed to, plan and track your activities. So that is fine. But when we're talking of software, I think baselining is very important because it's part of any software configuration management principle. So if you don't have a baseline, you wouldn't know what went into a vehicle. You need to know what features went in, what is the software corresponding to those features, and baseline becomes very important. And any change to that baseline, for you to upgrade a piece of software onto a vehicle, you need to track the changes to the baseline that is happening. So I'm assuming that it is linked to software. So in that context, I say baseline is a fundamental thing that you would anyway take care of when you're doing software development, software engineering itself.
Excellent. So I think there are multiple questions, but in interest of time, we have already shot over, but we will reach out to you with the other questions, etc. also. But in the meantime, Kiran, what I want from your side is 3 words, and this is more like a fire round. 3 words that you would like to use or suggest to our students so that they can become part of this exciting, new futuristic world of software and mobility. 3 words.
Yeah, sure. Thanks for that. I'll try to summarize. My own personal journey has been so exciting as an engineer. I think what each one of us should keep in mind is the passion to learn. Yeah. So as long as you are open and you're passionate about learning, engineers are meant to use the opportunity to solve problems, and that can only happen when we learn technology on a continuous basis. But at the same time, you need to know how to apply the technology to solve real-time problems. So just keep your mind open, have a passion for learning. Don't worry too much about not solving all the problems of the world. Technology not necessarily addresses all problems of the world. It's important to be very practical in our approach. So I would say as long as the passion for learning is there and how you know to apply the technology that you learn, I think most of us will be successful in our lives.
Perfect. Perfect. Thank you very much. So learnability, applicability, and solutions approach. So thank you very much. On that note, Kiran, thank you for sharing your experience. I think what you were able to share and enthuse these students was all your 27 years of learning and linking it with the new technologies, new things that are happening in the space, and how our students can become part of it. And I think that's where the future is. So dear students, I think this is a very, very interesting area for you to be part of, become a part of, because this is where the growth is in the future. And this is where, things are going to move. So in case you want to become part of this interesting industry, definitely there are multiple opportunities open for you. On that note, I would like to thank you, Kiran, and Funny for helping you change the slides and put up the slides, and helping arrange this web series conference also, web conference webinar also. So thank you to you, Kiran, and the Bosch team itself. Really appreciate your taking out time today afternoon and being with the students of Telangana. I would also like to thank all the management from various colleges, the principals, the TPO, the students who are part of this one. And of course, this was telecast on our YouTube plus our Facebook, as well as the TSAT satellite channel of Telangana government. So thank you everyone. And of course, Neja, thank you very much. And to HYSEA for partnering us. And we will see all of you after 15 days, after a fortnight, with a new topic. So be on the lookout for the new topic that we would be coming up with.
Yeah.
On that
Thank you
note,
from my side as well, Shrikant. It's been a pleasure being associated with TASK and HYSEA. I'd also like to thank all the participants in the webinar. It's a privilege for me, and I'm really looking forward to the new talent that will help us shape the future of mobility. Yeah, and the talent is out there. It's only about getting them into the industry, and we make sure that they are comfortable in developing, using technology and making lives better. Yeah. Thank you.
Yeah. Kiran, one more request over here. The request is that probably we would like some of our students to also see this firsthand. So we would like to do some industry visits, etc.
Sure.
If that can be arranged, in one of the Bosch plants over here or the software factory or whatever.
Sure, we can do that. We can arrange that, Shrikant. We'll be happy. Yeah. Thank you. Thank you, guys. Bye-bye. Thanks, Nirja. Bye-bye.
Thanks, everyone. Bye-bye.
And that's another wicket. Looks like game over.
The fantastic scent of Old Spice Dio gets you off the back foot and makes you the man of the match. Old Spice.
Hey guys, I hope that I'm live right now. If you are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Hello everybody, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Okay, that's great. So there's no issues with anything. Amazing, guys. Good evening, everybody. Good evening. Good evening. So, how are you guys? Do let me know. How is everybody? Bhaiya, give me more tips for competitive programming. See, competitive programming is all about practice. First of all, your data structures and algorithms should be like to the point itself, and then practice as much as you can. That is it. Like it's all, see, nobody's born a genius. Everybody, as long as you're working hard, as long as you're practicing, the better that you will be. So for the first 4 to 6 months, I was shit in like competitive programming. I wasn't able to solve any questions or something like that, but I did it for almost 2 years. Like, even though I knew that I'm not like able to solve questions, I'm not able to understand questions, but I persisted through it. You shouldn't feel as if like, yeah, this is not something that I'm able to do. Anybody can do anything. Okay, you just need to make sure that you are doing it at the end. Okay, and every single day. It shouldn't be like today, like I'm doing it, tomorrow I won't be doing it or something like that. Okay. See, DSA is like theoretical. So if DSA, if you're not able to solve the questions, that means that you haven't studied properly. Okay, so DSA, you have a fixed set of questions that are there. There's a fixed set of rules that are there. You need to understand that, solve at least 20-30 questions in it, and then try to like solve it on your own. Okay. Great. You want to come to the boot camp? Okay. Okay, guys. So how was your day, everybody? How was your day, guys? Which is better to get a job, CP or development? So it's the exact same thing as asking as if what is better, like breathing or eating food. Okay, so you have to do the both of the things to keep on living. So that's the same thing with development as well as CP. You have to do both of them to get placed. You cannot do just one. I'm talking about good placements. Okay, I'm not talking about some shitty startup or getting like a job in some small ass company. I'm talking about big corporates. If you are aiming for these companies like Google, Microsoft, Amazon, Atlassian, then Wells Fargo, Goldman Sachs, then you have to do both of them. Okay, just doing one wouldn't be possible. Okay. So backend web development day 7 is done or not, please tell. So we decided up that the postman session that we had will be considered as your last session.
जरिए इससे मुतालिक पढ़ेंगे। बच्चों, अफसाना दूसरा मौसम जो हम पढ़ने जा रहे हैं उसमें एक किरदार है, एक खातून है जो कि टीवी की एक खबर देखती है